everything. Okay. All of a sudden, I lost my students. Okay, so cosine x equals 0. There are two options, if you remember, up here and down here. So x equals pi over 2 and x equals 3 pi over 2. And sine x equals -1. It happens that it's the same. I don't have to write it again. It's that 3 pi over 2. So back at pi over 2 is 0, and 3 pi over 2 is 0. Sorry. At pi over 2 and 3 pi over 2. Okay. Now we have to study the sign. Not too difficult, because I'm going to plug in 0. When I plug in 0, this is 1 and this is 1. So this is 1 and this is 1, so it's negative. When I plug in pi, this is 0, so it's still here 1, and this is -1 times -2 is positive. And then when I plug in 2 pi, I get the same thing with 0. So this is 1 with negative, and this is 1. Okay. So I do have to plug in pi over 2 in the function and 3 pi over 2. So where is my function? Right here. When I plug in pi over 2, this is 0. This is 1 with -2 will be -2. When I plug in 3 pi over 2, this is 0. This is -1 with -2 is 2. Okay. Where am I now? Yes, to establish the two rows. Okay. So -1 down to 0, yes. 0 down to -2, yes. -2 up to 0, yes. 0 up to 2, yes. 2 down to 1, yes. Yay! So now the second derivative. Let's see what that brings. Messy. Quite messy because I have a product. Okay, so let's see. Can we figure out what happens here? Yes, because this is a local min and this is a local max. So if it's a local max, we know that the function, the second derivative has to be positive, but I don't know where the inflection point is. And I know that it's a local minimum, so obviously the second derivative has to be negative. It has to be positive because the function holds water. Here it has to be negative because it does not. But I have to find it, because if I don't find it, I can determine the points of inflection. At least one has to be. Okay, so I'm going to copy f prime, which is -2 sine x cosine x minus 2 cosine x. And this is messy because I have to use the product rule. Okay, the second derivative then. Keep the -2 outside, don't bother with it. Sine prime is cosine times cosine will be cosine squared plus sine times cosine prime, which is negative sine x. I'm going to change this into a bracket. And then cosine prime is negative sine, so plus 2 sine x. But I want to erase this parenthesis. Okay, let's see. -2 cosine squared. And this is negative sine squared with minus in front. So negative sine squared with, so that's positive 2 sine squared and plus 2 sine x. Messy because I have to keep the sign but change this again, as you told me before, 1 minus sine squared. Okay, I distribute -2 plus 2 sine squared plus 2 sine squared plus 2 sine x. Nothing works here. Ugly. Okay, so the second derivative, 4 sine squared x plus 2 sine x minus 2. I will factor out a 2. Ah, there is some hope. There is some hope. 2 sine squared plus sine x minus 1. There is hope that this is factorable. Yay, I think it's not too bad. But now let me just check. I just want to check my calculations. Negative 2 sine prime is cosine times cosine. That was okay. Sine cosine prime was this. Cosine prime is negative with yep. So negative 2, that's correct. This was negative positive 2 sine squared plus 2 sine x. Yes. This was with, I distributed here was negative and here was positive, positive, positive. Okay. So 4 sine squared, yes. 2 sine squared minus 2. Okay. I factor out a 2 and I get 2, 1, and negative 1. And I think we can factor this as, I need a plus here and a minus here. So 2 sine x minus 1 and sine x plus 1. Let's check. 2 sine squared plus 2 sine minus a sine. Yay! Okay, good. They worked hard on this one. So the second derivative equals 0 gives us two options. Sine x to be 1/2 and sine x to be negative 1. Okay. I don't know if I have room in my table. I don't really have room in my table. I have to probably build my table again. See, I told you it's going to take a long time for trig functions. So this has two options because one in the first, one in the second quadrant. X equals pi over 6. And this is pi minus pi over 6, which is 5 pi over 6. And this one is only 1. Sine is negative 1 at 3 pi over 2, which is here. So pi over 6, 3 divided by 6, so it will be here. And 5 pi over 6, can I squeeze it in? I don't like to do that, but okay, where is 5 pi over 6? I need to, so 5 times pi, and divided by 6. It's 2.61, so it's before that, yes. So 5 pi over 6. 5 pi over 6, and there is a 0 here. If you want me to rewrite it or remake it, I will gladly. Okay, so these are the zeros of the second derivative. But yes, now I have to find the sign. With 0, it will be negative. This is 0, and I have the up. With pi over 2, this will be 1. Yes, it's going to be positive. With pi, 0, 0. Yep. And with 2 pi has to be the same thing. So 0. So this is negative. So negative, yes. Wait a minute. With 2 pi, this is 0, negative. If this is negative, this is a local max. Oh, I see. Yep, because it's at the same point. Yep. So let's do this again just to make sure. With pi, this is 0, this is 0. 2 times negative 1 times 1 is negative. And now with 2 pi, the same thing. This is 0, this is 0. 2 times negative 1 times 1 is negative. Do I still have time? Yes. Okay. We have time to graph it. Now we have to do it. I'm going to take, so the maximum is 2, the minimum is, yeah, so I forgot one more thing. I have to determine the function value here because I don't know the inflection point. This is an inflection point. This is another inflection point. This is not not inflection point, because the derivative doesn't change sign. But I have to plug in the function pi over 6 and then 5 pi over 6 to get these values. Okay, with pi over 6. Pi over 6, this is the square root of 3 over 2 or 3 over 4. So f of pi over 6. One more time, yes, 3 over 4. With pi over 6, this is 1/2, so it's minus 1. So this will be negative 1/4. Negative 1 over 4. With 5 pi over 6, with 5 pi over 6, what do I get? Still the same thing because it will be negative, so it's still going to be 3/4. And this with 5 pi over 6 is still 1/2. Yes, it's still the same. Negative 1/4. Yep. Okay. So let's see what scale I want. I'm going to use pi here, 2 pi here. This is pi over 2, and this is 3 pi over 2. I'm going to say that this is 2. I'm going to say that this is negative 2. Okay, ready. Let me use a different color now. At 0, the function is 1. Fine. It will decrease to negative 1 over 4 at pi over 6. If this is pi over 2, I divvy up in 3 equal parts, then this is pi over 6. And it's negative 1/4. Somewhere here. I'm thinking for a second. I realize that it cannot be negative 1/4 because the x-intercept, let me check, where is pi over 6 again? So pi divided by 6, it's, ha ha ha. See how I catch my mistakes? Pi over 6 is beyond 0.422, not before. Because it makes no sense. It doesn't have an x-intercept yet. I was trying to graph pi over negative 1/4, but the x-intercept is here, not before. So it doesn't belong there. So here it is, negative 1 over 4. It makes sense. Okay, so decreases to, and that's where the inflection point is. I will have to redo the table because it's too squeezed in and you may have difficulties understanding it. Yep, that's with the trig functions. I warned you. Which page am I on? I'm on page 13. Okay. So let me put these in the correct order. 0, 0.422. Then I have pi over 6. Then I have pi over 2. Then, now I'm checking again, because I made an error with that. I'm going to check again. So what was 5 pi over 6? 2.61, and that is correct. So 5 pi over 6. Then 2.719. Then pi. Then 3 pi over 2. And then 2 pi. I should have graphed it on a table on landscape instead. But that's okay. I think it's okay now. See, the most important thing is to be able to say it's not right. That's the most important thing. Okay. So we have a 0 under pi over 2. We have a 0 under 3 pi over 2. And we have this sign for the derivative. That is clear. We have this number, which is 1. We have this, which is 0. We have negative 1 over 4. We have negative 2. We have negative 1 over 4. We have 0. We have nothing at pi. I don't even want it there then. I should have not put it in. We don't have anything at pi. I needed it so to establish the distance between. And this is a 2, and this is a 1. Okay. So it's decreasing. Yes, that's correct. Yes. Increasing. Yes, that's correct. Yes. Yes. Okay. I'm okay now. It's the inflection point. So this is a local min, and this is a local max. The inflection point is at pi over 6. And the other inflection point is at 3 pi over 2. And this was negative. This was positive. Till the 5 pi over 6. And then negative all the way. The second inflection point was at 5 pi over 6. And there is no third one. Okay. I'm glad that we have the new one. Okay, so opens downward, upward, downward, downward. Okay. I only need, I want to go back to where I started it actually. Okay. So here is my table. So that was correct at pi over 6. Okay. So the function starts at 1. It crosses at 0.422, and again pi over 6. Pi over 6, so it's 0.5. This is 0.422. So somewhere here. That's the x-intercept. Then at pi over 6, that's correct. It's negative 1/4, so it's this point. Then at pi over 2 is negative 2, so it's this point. At 5 pi over 6, which is here, right here, it's negative 1/4. At negative 2.71, which is before pi, this is 3.14, this is 2.71. I want to see if, so this is beyond, so this is pi over 2, 5 pi over 6. This is 6 pi over 6. So pi over 2, 5 pi over 6 is closer here. This is the point, 5 pi over 6. Closer to pi. 30 degrees or pi over 6 away from pi. Yeah, finding these points correctly is, okay, so 2.71 is the x-intercept. And again, 5 pi over 6 was 2.6. This is 2.7, slightly to the right. Okay, that's another x-intercept. Fine. And then at 3 pi over 2, it goes to 2. And at 2 pi goes to 1. And it's not done. We only plotted the points. Okay, now we're ready. It's opening down to this is the inflection point, and this is the inflection point. I want you to have those there, and that's it. Okay, so it's coming down from 1, crossing, getting to the inflection point, opening down. Then it changes concavity. It goes to pi over 2, negative 2, opening up. I didn't mean to make it so, I really want it closer, but that's fine. Opening up, going to another point of inflection, which is 5 pi over 6 negative 1/4, where it changes concavity. It crosses the x-axis at this point, changes concavity here, crosses the x-axis, and going to a local max, opening down and increasing to 2. And then it has a local max, and it continues to open down to pi comma 1. This is the function. And the calculator will not give you more details. I guarantee you. If you want to check the graph, let's put it in y equals. Like 5 pages ago, I had my function. Cosine x. So I need to put it squared. So parentheses, cosine x, close the parenthesis, and another one, and squared, and minus 2 sine x. Okay, and I'm going to change my plot because I had my stats class this morning, and I'm just going to turn that off. So you don't have to do that because I'm sure you don't have anything in stat plot. Okay, so I have that. Now I need the viewing window. So this is very important. I know that the action is between 0 and 2 pi, and only between negative 2 and positive 2. So I'm going to go a little further, negative 3 to 3, 0 to 2 pi. So x minimum, 0. X maximum, 2 pi. And I want the scale of maybe pi over 6. Y minimum, negative 3. Y maximum, 3. And I'm going to press graph. The calculator is not as sensitive as, or doesn't know as much as you do. Can calculate more, but it doesn't. It's not as sensitive. You know the inflection points. You are able to determine concavity and everything else. So as you see, this is the graph. But where is the inflection point? The calculator, I don't know if it can tell us. Thank you for picking that. It took, as I said from the very beginning, I warned you, these functions are a lot of work. And I'm glad that they worked out in such a way that the second derivative is nice, the first derivative is nice, but still you have to be very careful because you don't know the difference. It's difficult to tell the difference between 5 pi over 6 and 2.719. And they have to be in the correct order. I realized immediately that something went wrong. How can I have from 1 jump to a negative value without having an x-intercept? The function is continuous. So I said, uh-oh, I did something. And rightfully so, I put pi over 6 before 0.42, which is incorrect. Pi over 6 is beyond 0.42.